This is something I call the true history of compound interest with Sogrates and Amphibianes. You will play the part of Sogrates.
And Amphibianes plays the part of himself.
Through painstaking research, I have traced the beginnings of compound interest to ancient Greece. I've discovered a lost manuscript about the greatest philosopher of all time, though long since forgotten. At one time he was so great that people called him Sogrates. This manuscript describes a dialogue between Sogrates and one of his students, Amphibianes, who was always hopping all over him with questions. Throughout the following reconstructed dialogue, notice how Sogrates employs the Socratic method, by which a student is brought to knowledge through queries such as, "What's so great about that?" Remember, you are playing the part of Sogrates. Amphibianes is playing the part of himself. I will assist you with the Sogrates part, but please speak along with me.
Oh, great, Sogrates! My interest is confounding.
Your interest in what?
Compounding.
You mean your interest in compound interest has you confounded, Lily Hopper?
That's what I said, big guy.
What are you interested in compounding?
Money, of course. I want to get the most bang for my buck.
Amphibianes, you are in Greece. They don't use bucks here. The currency is the drachma.
Are you sure?
As usual, but that is beside the decimal point. The units don't matter if you are seeking to generalize a concept.
Hey, no need to comment about my eyes. I'm just interested in the most interest I can make on, let's say, 1 drachma, because I have to pay for all my tadpoles' college educations.
Okay, you have your principal, but what rate can you get and how long do you have till the tadpoles matriculate?
They're undulating already. But I don't know the principle, that's the point.
Principal, Amphibianes. That's what one calls the original investment.
What a friendly term. Okay, let's suppose that I can find someone who is willing to give me an annual rate of 100%.
Nominally?
No, not in some alley, at a legitimate bank.
Okay, suppose you left your drachma in the bank for 1 year at a 100% nominal rate. What would that amount to?
Well, that's easy. I can count that on my flippers. I know that interest equals principal times rate times time, so 1 drachma at 100% for 1 year would give me 1 drachma of interest, so now I'd have 2 drachmas, or is the plural drachmae?
Precisely, Hophead. Either way.
Ah, but my question is, can I get a greater amount?
So you want to compound?
No, I don't want to be confounded. That's why I came to you.
Of course. I mean, you want to compound the interest. For example, you can ask the banker to give you your interest after 6 months instead of waiting the whole year.
How does that help? I only get half the interest, so I'd have 1.5 drachma.
But, tasty legs, you could put the money back into the bank for another 6 months.
Oh, I see. Then I get 6 months of interest on the 1.5 drachmae, so I'd end up with, let's see, 1.50 plus half of 1.50, which is 0.75, which would give me 2.25 drachma. Wow, that amounts to 2.25 drachmae instead of 2. That's great, and even though my flippers are all twisted up, I know that I can even do better.
How could you do better, O Krogmeister?
I could ask the banker to compound the interest every 3 months instead, but I'm afraid the calculation would be confounding.
You mean compounding. Why not look carefully at the calculation that you already did, and then see how it would change if you compounded every 3 months instead?
Well, for the first 6 months, I took the principal plus the interest, 1 drachma plus 1 drachma times 100% times a half a year, so 1 plus 1 times 1 times a half, which is my first amount, and then that is my new principal, and I have to add the interest on that amount to itself. 1 plus 1 times a half plus 1 plus 1 times 1 times a half times 1 times a half. How does that help? It's kind of messy.
Factor.
Hey, don't use the F word. Oh, I see. If I factor out 1 plus 1 times a half, that amounts to 1 plus 1 times a half times 1 plus 1 times 1 times a half, which is just 1 plus 1 times 1 times a half squared. Interesting.
Now suppose you began with a different principle, like 2 drachmae.
Same thing. I'd get 2 plus 2 times 1 times a half, plus 2 plus 2 times 1 times a half, times 1 times a half, which is just 2 plus 2 times 1 times a half, times 1 plus 1 times 1 times a half. If I factor out the first calculation, this one doesn't look so nice.
Try factoring again.
Oh yeah, the F word. Oh, I see. 2 plus 2 times 1 times a half times 1 plus 1 times 1 times a half equals 2 times 1 plus 1 times 1 times a half times 1 plus 1 times 1 times a half equals 2 times 1 plus 1 times 1 times a half squared. So if I do the same calculation, the final amount, let's call it A for Amphibianes, would be A equals P times 1 plus 1 times 1 times a half squared for any principal.
Principal. Can you generalize for any interest rate?
Of course, if you notice that the third one in the formula represented 100%, for any rate R, the amount that I'd have after confounding twice a year is always P times 1 plus 1 times R times a half squared. But I still want to confound it more.
So what will change in your original calculation?
I'd start with 1 plus 1 times 1 times 1/4 instead to get the amount after 3 months, and then my next calculation would be 1 plus 1 times 1 times 1/4 plus 1 plus 1 times 1 times 1/4 times 1 times 1/4. Hey, I can factor again to get 1 plus 1 times 1 times 1/4 squared after 6 months. Doesn't take a genius to see that the final calculation would yield 1 plus 1 times 1 times 1/4 raised to the 4th power.
What's so great about that?
Don't you see? If I confound n times a year, it'd be 1 plus 1 times 1 times 1 over n raised to the nth power. And with a different principal and interest rate, it'd be p times 1 plus 1 times r times 1 over n raised to the nth power.
Principal. I feel like a GPS on a joyride. What if you left the money in the bank for 2 years?
Those confounded factors would just keep going and going, like the Energizer toad. So, P times 1 plus 1 times R times 1 over N to the 2 to the nth power. In fact, for any amount of time t in years, A equals P times the quantity 1 plus R over N raised to the nt. But you still haven't answered my question. What's the most confounded I can get? Would I get a better result confounding every month?
Try compounding every month and see.
For 1 plus 1 times 1 times 1/12 raised to the 12th, I use my TIBCE calculator and put in 1 plus 1/12 raised to the 12th power, and I get about 2.61 drachma. So it's better. Hey, rather than type all this in, I'll put y1 equals 1 plus 1 over x raised to the x power and just input values in the table. So let me try weekly and daily. Putting in 52 for weekly, I get about 2.69. 365 for daily gives me about 2.71.
How about every hour?
I don't know how many hours there are in a year, so I'll just enter y1 of 365 times 24. It's approximately 2.718. Not much better.
Keep going, weed hopper.
Every minute, y1 of 365 times 24 times 60 is about 2.71827. And every second, y1 of 365 times 24 times 60 times 60 is about 2.71828. Looks like no matter how many times I'm confounded, I max out at about 2.72 drachma.
Try every millionth of a second. Yes, do it. The answer may surprise you.
Confound it! I thought the max would be 2.718.
It is.
But my calculator says it's 1.
It's wrong. This time your calculator is the one who is confounded. The limiting value that you approach is a magical mathematical constant that, in the future, will be called E.
You mean, as x gets very big, quantity 1 plus 1 over x raised to the x approaches e? Isn't that like saying the quantity 1 plus 0 to the infinity power? Shouldn't 1 to the power of infinity be 1? I don't understand what you mean by a limit.
Nobody does. It requires calculus, something that will be invented by Newton and Leibniz in the future. It will prove that your naive assumption of 1 is incorrect.
Calculus? You mean small stones or tooth deposits? Okay, I'll just accept it. But does it simplify my formula, A equals P times the quantity 1 plus R over N to the NT, when I let N, the number of periods in a year, get arbitrarily large?
Yes, then it simplifies to A equals P times e to the RT power, where e is the magical mathematical constant.
That would be easy to remember if I had any hair.
What do you mean?
I'd use Pert shampoo. Get it?
And that is the true story of compound interest. Honest.